Welcome all to the new session Computing Functions with the Turing Machine. Myself Dr. Sunitha from KL University. So the aim of the session is to provide an understanding on the computation of functions using Turing Machine, and these are the instructional objectives and learning outcomes. So computing functions with the Turing machine, how we can make use of Turing machine as executor for the functions. So a function f of w has a domain D and result region S. So in that case, w input w is belonging to D, the domain, and after execution the result should be belonging to its the region S. Okay. So a function may have parameters. Example, addition function f of xy is equal to x plus y. So x and y are the input, it is in the domain D, and x plus y is in the result region S. Then before moving on to that, how we represent these numbers or integers in Turing machine, how we are going to represent them. So if we have a decimal number 5, in binary we represent it as 101, but when we come to Turing machine we represent it in using unary representation. So unary means we are going to use only a single symbol to represent any number. So if I want to represent 5, I will use 5 ones. So 1 is the symbol that we are using here. And this is easier to manipulate, that is why we use unary representations in Turing machines. So a function f is computable if there is a Turing machine M such that initial configuration is like this, that is the input is there on the memory tape and the system is in state Q0 and it is starting. The arrow, the read head is at the beginning of our input symbol, that is the initial configuration of our machine, and after execution the configuration should be like this. This function should be calculated, f of w has to be calculated, and the machine should reach the final state QF and the read head at the beginning of our output. If this configuration, final configuration is possible, then this function is computable. For example, this is the initial configuration Q0W, that is Q0 is the initial state and W is the input, and after many transitions it should reach QF. The configuration should be the QF f of W. F of W is the answer of the function. Then a function f is computable if there is a Turing machine M such that it can go through these configurations from this initial configuration to this final configuration. So let us take an example. Function f of xy is equal to x plus y is computable. Okay, x and y are integers, those are the inputs, and the Turing machine first initially the input string will be like this, x 0 y. So x is represented in unary representation, y is also represented in unary, and they are separated with the number 0. Okay, so 0 is used as a delimiter here, and after the execution of x plus y, the output string or the memory tape should contain x y 0. That is, the delimiter will be at the end to show that that is the end of our output. Okay, this is the method we are going to use here. So initially this string is, the memory tape is like this. So first we have the first operand of our operation of our execution, x. So that is represented in unary. So all ones are there. So if x is equal to 10, 10 ones will be there. Then it is separated, delimited with a 0. Then the next operand will be written. So everything in unary, and that 0 is actually a delimiter that separates the operands, and the machine is at Q0, read head at the first one of our input. Okay, that is happening. Then after execution, after the Turing machine computes this function, the memory tape should be like this. So there the first beginning we will have x plus y number of ones, and at the end we have the 0, and the machine is at QF, the final state, and the read head at the beginning of our output. So this should be the final state. Then this is the initial state. Start state should be like this. We have two operands separated with 0, and at the final state what we have the answer, and at the end we have the 0, to show that this can be used for further processing. That is why we keep the delimiter 0 there. Okay. Then let us take this machine. Okay, so this machine, this Turing machine computes f of x y is equal to x plus y. So the initial state is q0 and there is a self loop 1 arrow 1. That means if 1 is there, keep 1 there itself and move the head to the right. That is 1 arrow 1 comma r. And this transition says that q0 to q1 0. If we find 0, make it as a 1 and move to the right side. And the self loop on q1 says that if there is a 1, keep it as such and move to the right side. And this q1 to q2 transition says that if there is a blank symbol, keep it there and move to the left side. Then when we find a 1, make it as a 0, then move to the left side. Then in q3 the self loop says that keep all the 1s there and move to the left side. And once we reach the blank symbol, we move to the right side. That is the machine says. So what is actually happening here means, okay, we are going to make this 0. Okay, we are not going to touch these ones for the first operand, and when we find the 0, we are going to make it as a 1. Okay, then again skip all the ones here on the right side, and when the last one should be made 0. That is the only thing we are going to do. So this 0 will be made 1 and this last one will be made 0. That is the operation we are doing. So this is the transition, this transition q0 to q1, this transition is actually changing or toggling the first 0, that delimiter 0 to 1. And this transition q2 to q3, this transition is actually changing the last one into 0. In all other cases, we are not touching any 1 or any other symbol there. Okay, any blank symbol or any 1 we are not touching. Only this 0 will be made 1 and the last one will be made 0. That is the thing. So let us take this example. Let x is equal to 2 and y is equal to 2. Then the unary representation is 1 1 and 1 1. So the memory will be like this, 1 1 0 1 1, and the final answer should be like this, 4 1s at the beginning and there is a 0 at the end. So initial case we are at q0 and we are going to process the input 1. Okay, so when we see the 1, the transition, this self loop will take, it will just skip that 1 and move to the right side. Okay, still we are in q0. Then we take the another 1. Again that 1 is, we are not going to alter that 1, just to move the head to the right side. So we will reach this 0. So when the 0 comes, we have to change that 0 into 1, then move to the right side. Okay, so this will be done and the state change will be there, q0, we will move to q1, q0 to q1. Then now the read head is here, so 1 we are not going to make any change on this 1. We have to make the last one as 0. That is the only change we are going to do. So whenever we find 1, we simply move. Okay, so in q1 itself. Then again we find a 1, again we will move to the right side. And when we find delta or this blank symbol, we understand that we are at the right end of our operands. So immediately next to this blank symbol there will be our last one. This last one has to be made to 0. So that is done here. This last one is made to 0. Then we have to move this read head to the beginning of our input values. So we are going to move one by one. Okay. Move to the next position, then move to this next position, then move to the next position. Always we are skipping the 1 and move to the left side. So okay, left side we reached here, and when we find this blank symbol, we understand that we are at the leftmost end of our values. Okay, then move just to the right side to reach our first position of our input or our output value. Okay, then we reach to the final state and it is the acceptance state and the machine halt there. So the answer is ready on the memory. Okay, this is how this addition function is working, x and y. x plus y. Okay, then how we can do the multiplication of two values. Okay, how the Turing machine can be used to compute this function f of xy is equal to x into y. So the function has two operands, x and y, and after the execution we should have x into y, that is the multiplication of these two values on our memory tape. Okay, we are going to take this one f of xy like this. Okay, so the operands are separated with 0. Okay, let it be y is equal to 3 and x is equal to 2. X is 2 and y is 3, so they are separated with a 0. 0 is the delimiter here. So the logic behind this multiplication is repeated addition. Okay, 2 into 3, I can add 3 two times. Okay, so this can be like this. So if I have a 2 into 3, I can add this 3 two times. 3 plus 3 will give me the answer 6. Okay, so that is equivalent to 2 into 3. And if I have a 2 into 3 into 4, something like this, 3 into 4, I can do 4 plus 4 plus 4. Okay, 4 times the addition, so it will give 12. So it is equivalent to 3 into 4, 12. Okay, so here in Turing machine we are going to do the multiplication using the concept repeated addition. So instead of using the direct multiplication, we are going to apply repeated addition. Okay, so the logic is, wherever we have this operand, wherever we find this 1 over here, we are going to copy this value, this second operand, to the right side. Okay, then whenever we find the next one, again we will copy the same thing to the right side. Okay, so first when we read this first one, we make it as a blank symbol because we have already considered it. So we'll make it as 1, and what we have to do, we are going to copy this y to the right side. Again we have put a delimiter there and move to the right side, copy to the right side. So this y is copied once. Okay, when this one is over, we'll one time copy is also over. Then we consider the next one, we take the next one. So this next one we made it as blank. Then by the same time we have to copy this y again to the right side. Okay, so we have copied this y again to the right side. So this is the one that we copied earlier, and this is the second time we copied. By that time these two values are over. Okay, now what we have to do, the copying operations are over. Now we have reached this 0. This, when we find the 0, that means we have completed our copying operation. Now we have to make all these values as blank. Okay, that is the next step we are going to do. Then the final remaining answer will be 2 into 3 is actually 6. So we have 6 ones over here, 6 ones over here. So the remaining things we have to make as blank. That is what we are going to do in the next step. So the copying is, when we reach the 0, we understand that we have reached the end of the copying operation. Okay, now what we have to do, we have to make all them as blank and the answer remaining there. That is here, that is it. And how we can draw the transition function, transition diagram for this Turing machine. So the concept is this. So we start with Q0. Okay, so Q0, and when we find 1, so when we find the first one, we have to make it as a blank, okay, or that diamond symbol. Then move to the right side. Then move to the right side. Then we have to skip all the ones until we reach the 0. Okay, so when we reach the 0, we know that sorry, so after this 0 we have ones. Okay, so the second operand will be there. So that second operand, in that second operand, all the ones we have to make it as, we have to copy to the other side. Okay, so first one we will make it as an AX, sorry, not this one. So this when we find the one we will make it as AX and move to the next state, and we are going to copy to the other side. Okay, so all the remaining ones we have to simply skip and move to the right side. Then when we find the blank symbol, when we find the next 0, one more 0 is there at the end of this thing, so we have just copied. Okay, then the next blank symbol we have to make it as a 1. So we are going to do this copying. Okay, so if we have 1 1 over here, okay, so this first blank symbol we will be made as 1 up to this. Okay, so this blank symbol we will make to 1. Then we will move to the left side. Okay, so move to the left side, and we will skip all the ones and all the zeros and move to the left side. And when we find this blank symbol, so this is made blank, when we see the blank symbol, we will again go back to, when we see the blank symbol, keep it as such and move to the right side. So in this part we are going to do the copying operation. Whenever we find this blank symbol, we'll move here and we will make the next one as blank, next one as, sorry, this is sorry, not this one. Sorry, instead of this, this is not B, this is EX. Okay, so first one we made EX. Okay, so when we find EX, we will move to this thing, and we will we'll take the next one and again make it as an AX, then go back here and make this copy as 1, this as 1, like this it will continue. Okay, and this is also copied. Okay, this is also 0 will also be skipped, like this. Okay, so this will be copied, and this 1 and 1 will be copied, so all the 1 will be changed and all the ones will be copied. So like this we'll continue. Okay, okay, this one is skipped. So when we find this blank one, it will go there. When we find the blank, we will change it to 1 and go back. Okay, likewise. And when we encounter a 0 instead of this one, instead of this EX, immediately next to this, if we find a 0, that means we have completed all these copying. Okay, then what we have to do, we have to again move back and change all these EX to 1. Okay, we have to change all these X back to 1. All the when we find 0, we have to move back to left side and change all the X to 1. Okay, move to the left side. Okay, then when you find 0, we have to move back to when you find 0, we have to move back to the left side. Okay, likewise we will complete. Okay, so when we reach all the ones, X arrow 1. Okay, so whenever we find this ex, we will replace it to 1, and when we find 0, what we have to do, we have to move to another state. Okay, when we find 0, we will move to left side. Okay, then whenever we find all the ones, we will move to the left side. Okay, then when we find this blank symbol, we move to the right side and do this. Okay, then immediately next to this, if we find a 0, we put that 0 as blank and move to the right side, and then Q7, when it find all the ones, we have to make as blank and move to the right side, and 0 move to the right side, and this is the acceptance. So this is the final machine for the multiplication. Okay, so that is we are trying to explain how we can use the Turing machine for computing some functions. Okay, so Turing machine can be used as an acceptor, and at the same time it can be used for computing functions as well. Okay, that is all about this section. Thank you all for patient listening. Thank you.